which gives me an opportunity to wear the hat of the lab representative and developer in front of customers, and also wear the hat of the customer in front of the developers in the lab, to carry the message both ways about what is important for making applications performing well in today's world. And I wanted to share a few of those things that I have seen through those trips to customers and interviews. So to just add to that message, which has been coined by Sun Microsystems back in '84, I think. The network is the computer. Don't forget about the network, because if you do, where things may start to happen with your application that you wouldn't even expect. So in order to look at that complex system of the network and applications working together, let's take a parallel of looking at the restaurant. So if you have an application that works on the infrastructure, that works on the network, that serves the application transactions to the end users who are doing something with it, how would you know that everything works fine? So we start with the infrastructure monitoring, which is to have a look at your kitchen and the way how the cooks are making the dishes. You look at the process, which is overlooked by the chef. So it's all created well. And then it is displayed in the menu or to the display, so we can choose your dish. Of course, there is a network of waiters that is delivering the things to the consumers, and finally presented at the table, and you are happy. Are you? That's not the thing that you are coming for to the restaurant. You come for totally different things. You come to have good time with the friends. You come to have good food. You come to have the experience that will let you to come back there later on and have the same thing. These are the influencers that make your business decisions and that finally influence those who are the restaurant owners. So it's not about monitoring the components. It's about monitoring the end-to-end picture. And it's becoming even more difficult if you look at this from the perspective of the IT systems. Because this kind of interactions that we have just seen, they occur at many tiers of the application, throughout the application delivery chain, down to the data center deeps where we have databases and middleware systems and things like of that nature. Having looked at them all together and knowing how the transaction performs end-to-end, it's really challenging task. Without it, you wouldn't know what's going on. So people found out this many years ago, more than 20 years ago, and depending on where you sit, on the network side, on the server side, there are good ways of looking at those two disciplines. Those who start their experience with the network side of the things, like Gary, they will always argue that Sniffer is the best thing in the world and we don't need anything else because packets never lie. That is true. On the other hand, you have those guys who look at the servers and they say that logs tell you everything, that the system monitors tell you everything. You don't have to know anything else. If your CPU is okay, everything should be fine, right? Well, sometimes yes, sometimes no, as we will learn. There is also another approach, which is the discipline that has been coined just a few years ago, and it has different names. Sometimes it has been referenced as application-aware network performance model. That is a combination of those disciplines. Instead of looking at one or another, we look at both at the same time to provide a holistic picture. You can compare that to having a good variable zoom lens in your back pocket, where you can really look at the scene which you would like to capture in picture and have it captured right away the way you like it and with the perspective that is best at a particular moment in time. So let's step back and look at the things that we have just learned from Gary, how complex the network transactions are. Let's recap how the typical connection setup looks. So it starts with client sending the connection request to the server, and then we see the connection established, and then we see the request being sent from client and response from the server, and everything is fine. So we've got some information from client to the server and from server back to the client, and the things that we have seen by now we can characterize by those measurements that Gary also referenced, like number of TCP packets, bytes, round-trip time, loss rate, probably errors that may have occurred on this TCP connection setup, and so forth. Would it tell you whether, looking at this restaurant example, whether the food was good? Not yet. We have just measured the temperature of the cooker in the kitchen. If you are the application developer, you will probably look at your requests and responses in the heaps. They are riding on top of those TCP connections. So when you look at the JSP pages or the objects, you already are one layer above. But do you, at this moment in time, reflect what really the users are experiencing with your requests and responses and the TCP turns and the hits? Probably not, because the users are coming to the application to execute concrete tasks. That could be like a book a trip on the website, the online holiday shop, or maybe conclude some transaction within the enterprise, like to approve your new cell phone plan or whatever. That is still one step beyond what the business is doing, because those who are sponsoring your applications, they are looking at something else. They are looking at your productivity, efficiency. They are looking at your ability to make those tasks happening. And it's a complex system. So looking at all those components together is the only way to understand whether all the ingredients are in place, whether all the processes are working together. And that is true, that network packets never lie. You can look at them from the network perspective, but you have to do it in a smart way. That is, to analyze the network protocols top-down to understand what's going on with the application. Otherwise, it's like looking at the air molecules moving in order to find out where the wind is blowing. That's not the way to go. Here's a good example. The chart that I'm presenting here is a kind of one level up abbreviation from what we have been looking at with the TCP connections. Each of those segments in here is one of the exchanges. There is request from the client, then the server processes the request, then there is response from the server, and then there is another and another and another. Sometimes we call those charts the waterfall diagrams or the sequence charts. This is representing one of the transactions in the production system in Oracle Business. So the request has been sent from the client, some data has been processed by the server, the response arrived back, then another request has been sent from the client, and so on and so forth. And 17 seconds later, the screen of the operator has been populated with the information he wanted. From click to glance. Sometimes it's called that way, click to glance time. 17 seconds in this case. Now, when you look at that chart, you can see that some of those boxes are red, and there is also a lot of white space in between them. Some are green. The red represents the server processing time as it has been measured. The empty spaces represent the client time, that is the time when the client was quote-unquote idling, doing nothing, or processing, and still not sending another request for data that has actually been expected to be sent. So looking at that chart, what would you conclude? Where's the problem with this 17 seconds? Where would you jump to fix that issue? Well, each individual of those requests is processed pretty constantly and pretty fast by the server, so you can predict that the server response time is predictable and it's consistent, not a problem, probably. When you look at those gaps in between those places, you can see that probably there's something going on the client station. So working at the large enterprise, you may consider upgrading your desktop because they are too old for that application. In reality, if we look at details, what's going on within those transmissions, if we take one step down to look what exactly is the client telling and what exactly is the server telling, we uncover what is the logic of that application which is using the network. And that logic is really tricky, because with each of those requests, what's going on is that client is actually polling the server for answer. In first request, it is sending the data that is really needed to process the transaction, and then it is continuing to ask the server, did you already process my request? And the server responds, no, wait half a second more. So the client waits and then sends another request asking the same. And the server says, no, wait more. And now when you look at those steps here, you see that pattern here, that they are longer and longer and longer. Finally, the processing stopped here, and here is just the response down. So looking at this chart from that perspective, having knowledge of how the application works, we can clearly tell that it is the server that is slowing down here, and it's slowing down tremendously because all this processing is occurring in sequence, not even in parallel. So with this kind of complex system interactions knowledge, we can clearly tell where are the problems with the application delivery. The thing becomes even more complex when we look at how the application is being delivered. Because it's not only that there is a connection between client and server over the proverbial network. The proverbial network is this. That's the part that we sometimes call application delivery channel, and it is comprised of multiple components that have to work together. Only then the response is delivered good to the client. If we look at the clients who are sitting on the internet, that's sometimes pretty easy because we have just the firewall, probably some security proxy, and then we are right on the application server. If we talk about applications that are delivered over the enterprise networks, that is much more complex and may include different components also, as Gary mentioned. One optimization controllers, proxies, sometimes load balancer devices, and so on and so forth. Looking at all those elements in conjunction, only then we know where are the application performance culprits and how to fix them for the benefit of the user who is using that application at the end of that chain. How to do it? Well, again, you can look at the molecules and look at all those systems in separation to see how they perform, but actually the better way to start is to look at this top-down. That is, having in mind what are those applications for. They are for serving some concrete transactions which can be named to the users, so the users can also be counted. They should be counted to know what is the business impact of poor performance. At the same time, we can look at how this particular problem, if we have a problem, develops over time. So we can clearly see whether we should react right now, whether it's mounting, whether it's already in progress or it's gone, what will happen next. We can predict from trending. We can also add some kind of synthetic monitoring to that picture, which will tell us what is the baseline, what is the typical repeatable application performance that we can expect from that complex system. Of course, we need to include that application delivery channel, which we mentioned before, which is a complex system by itself. And finally, looking within the data center at all the components in that simplified schematic way provides us what we call fault domain isolation. So I can quickly tell whether my problem is attributed to the network, to the server, to application design, which makes my life a lot easier. And the network itself, when we look at the network, it sometimes looks as a combination of disconnected influences. We have just touched upon all those components like load balancer, proxies, and run optimization controllers. And the things are getting even worse when we look at the virtualization, which is omnipresent today everywhere. Let's have a quick look at this. So all of you have probably touched virtual machines, and some of you have configured networks that are connecting those virtual machines. Is it easy? Yeah, it's easy. How it looks when you work with those two virtual machines connected one to another? It's like that. You have one virtual machine talking to another virtual machine. This one talks to many. Simple enough. Easy to set up, easy to do. That's how it looks from the logical perspective. That's what you deal with when you program the network. In reality, those virtual machines are sitting on some servers which are sitting in the racks within the data center, and those racks are connected to the switches that are on top, Those switches are connected to another layer of switches, and the connections are going between those. So you think that your virtual machines are connecting to one to another just like that from memory. It's not guaranteed. It can go through many different steps in the middle, and in reality, that call, which you think is just from one virtual interface to another virtual interface, may go through multiple points, through multiple processing units. It may even go through some long-distance networks before it reaches your machine. That's the danger of virtualization. Forgetting about this is a recipe for failure when you think about the network performance. Network is not unlimited. Network is not zero latency. Looking at those is necessary in order to understand what are the complex influencers of that application. So what it leads to? It leads to the constant and never stopping fight at the enterprises, where we have the server team, the network team, the application team, and there is a blame game. Each is blaming another for the fault. Network team has abundant tools to tell you it's not the network. They will prove you that with the interface utilization, with the latency measurements, and so on. Server team has those system monitors and logs and all the green lights everywhere. Virtualization team has its own set of tools, and so on and so forth. It continues. How to deal with that? Well, it's all about taking the right lens to look at the problem. We have a variable lens, starting with defining and framing the problem. So what is the issue first? Let's put it on the table and then start analyzing it. Then understand the impact of the problem and the end user perspective. Are you chasing the real problem, or are you chasing just the ghosts? And finally, when you have that information in context of the whole application perspective, the whole application delivery chain, only then you can find out where the problem is. And that is really the answer to the question, who sank the boat? Who sank the boat is actually a book for kids by an Australian author, Alan Anders, and it's a great illustration to children how lack of cooperation leads to this kind of disastrous events. And only when we look together at what we do together as a team, we can address those problems. So instead of blaming and instead of having this kind of negative fault domain isolation, not me, let's have the positive approach to look at the end-to-end, how the application is being delivered, and this way find out what's going on and where to fix it. I will show you a couple of examples from the recent interactions that we have with our customers, where this approach can really be seen how it works in practice. So this one comes from it's a company that's is a telco company. It is delivering the application for customer relationship management (CRM) to their partners who run the call centers. Running the call centers is outsourced to the third-party company. They don't own them themselves, but they deliver the application to the third party. So those consultants who are picking up the phones, they work on the application delivered by the telco company itself. So the situation in reality is that it's a long, complex application delivery chain. You have the data center where the application is being run. Then the application is delivered over Citrix, so application virtualization here, to the third parties who are sitting close to their desktops. And in the middle, there is the service provider who is providing the network connection. This kind of complex application delivery chain is experiencing what the users are calling application slow events. That is, their screens are freezing, they are slowing, they don't know how, they don't know why. Let's look at this application delivery chain. So there are the users, those who are sitting at this restaurant and consuming. It's only me who's breaking the frequency. Then there is a network, so the delivery of those applications be served there. There is a presentation layer, it's application virtualization from Citrix, and finally there is application in the data center. Looking at all those components together will tell us if there's something wrong, what is wrong. So looking at the Citrix performance end to end with this kind of picture, we can tell where is the problem. Is it at the application tier? Is it at the application delivery? Is it at the network? Or is it at the users? So in this case, looking at those four components holistically, it has been identified that the problem is not with the Citrix. So these are not the servers that are serving the application front. The problem is not with the application either. The SQL servers who are serving this application, they are responding fast and delivering the content to the Citrix servers in time. The third-party report for the network utilization from that service provider who was delivering the apps over the network to the third-party consultants, they reported that the network utilization is low. It's well below the bandwidth on that network that has been provisioned. So that was also not a problem. However, looking at the TCP analysis report for the Citrix ICA protocol as the screens are being delivered, told us that there are random packet losses occurring. And on those connections which are delivering the Citrix screens to the end users, that can be devastating because this kind of packet loss requires to be retransmitted, and when we look at the screen refresh at that time, the screen simply freezes. So when it freezes, it's difficult to work with, especially for consultants who are waiting for documents at this moment. So this was the reason why they were reporting those kind of application slowdowns or the freezes, because of the network performance issue, and that is really easy to find if you look at first the analysis of the TCP connections, and second, analyzing them in context of the application that those TCP connections are carrying. Because knowing this, we can tell that in this case, the problem was with those large images that were the scans of the documents, and they were freezing the delivery of those scans to the end user scans. Here's another example from a different customer who experienced random slowdowns with the application, but this time affecting everyone at one moment and then going away. And then a couple of minutes later, again, everything like stopped for a moment and then going away. And it was occurring throughout the day. So what we found out is that in this case, the problem was affecting every user and every URL of all the application at the same time. However, it was always starting with the same URL. Once this URL has been called by too many users, it stopped for a moment, and then it was recovered. So looking at the reports, we found out that the issue starts with the server response time for those URLs, and then it continues. With this kind of analytics that can be built in today's systems, we didn't have to look actually at the dashboards and reports for every single URL, because real-time analytics told us that the issue is with the data center response time for every URL. So the analytics has been performed in the back. We even call it sometimes artificial intelligence. It's a program intelligence that tells us what's going on in there. And with that kind of information, we could recommend the application team this time to look into the application code to see what's going on with those URLs that are starting this kind of avalanche effect on the application performance. And they found it, and they fixed it in our application service. Takeaway from this is that we have been looking really at the network first, and at the network packets, and from the network packet analysis we found out that we actually should look at the application service. Another example, this one I really like because it also alludes to this one optimization story that Gavin mentioned. We had a customer who was using the enterprise resource planning application, ERP, to instrument all its processes for production throughout the world. That's a company that is headquartered in the Netherlands and is making goods in the factories in China, in Malaysia, Indonesia, all the regions, while the ERP system, the SAP in this case, is hosted in the Netherlands. So immediately you can identify that there could be a network issue here that we are dealing with, because the network is broad worldwide, and those people in China who are in production and accessing the ERP system that is hosted in Europe, they may have problems with the network. That was, of course, identified here as well, that it is a network issue, clearly. So the service provider who was serving the network, one of the leading world providers, has been called in to do something about the network, to speed it up. What they did, of course, they have this kind of offer in their portfolio. So they said, let's add one optimization to your network, because that is obvious. If you have your users in China, you can't expect that you will deliver them on these days. All right, they implemented the one optimization controllers on both sides of that network. They implemented this worldwide. The situation didn't help. It actually got even a bit worse. So those SAP users who were complaining for the slowdowns of the system, they were still complaining. What happened? So when we look deep into the traffic to see and understand what was really going on within the traffic, we noticed that there are unusual things. So one of the TCP flow controls that can be applied when the applications are using the network is what is so-called client zero window size signal. The signal is being sent at the moment when the client who is receiving the information of a TCP connection has the buffers filled in and cannot accept more data. At this time, it will send back the signal together with acknowledge, together with ACK, telling that I have zero buffer left, stop sending until I process what I got already. And we have been seeing those events happening all the time. Now, what it means in the one optimized environment. Let's first have a look how this one optimized environment really works. What is the wide area network optimization is introduction of those devices on both sides of the long distance network, where the role is to speed up the application delivery. There are multiple methods of optimizing the network connections. We can optimize the payload by, for instance, compressing. We can optimize the TCP transport connections, for instance, by keeping the sessions persistent, as Gary mentioned before, or adjusting those parameters of the session that is established over those wide area network to make it faster, really, providing higher bandwidth or realized bandwidth for the users of that network. Or application optimization can be applied, like, for instance, caching or predictive loading of the content of the application, when the optimization controller may predict what else would be loaded over the same connection. There are multiple methods. Those devices are really complex and sophisticated, and with all those methods applied, the applications should really be delivered faster over the wide area networks. However, when we look at the detailed reports to see how it works in practice, we may find out things like this. Total bytes compression applied by the payload optimization on those one optimization controllers is negative. That means there is more traffic on the network now compared to the situation where those controllers weren't present. What an optimization. Then, when we look into those client zero window size events, we can see that they are occurring like all over the place. from all the locations, and actually the larger location, the more traffic, the more of those TCP zero window size events being signaled over the network. Now, if you recall how this one optimization is built, you will now know that they are not coming from the end users. They are not coming from the clients. They are coming from those one optimization controllers. So now it means that this service provider is really now cheating on me. He did something wrong with those one optimization controllers. But what's the problem? When we look at the applications that are being transmitted over that network end-to-end, and when we look at the compression ratio or the optimization ratio for those specific applications, now the picture becomes clear. We have applications like SAP, and we have applications like SAP over HTTPS. Both use heavy network encryption. This traffic is encrypted. When it's encrypted, it's also compressed. Now connect the dots. What's happening? We are compressing already compressed traffic. It takes a lot of CPU power on those one optimization devices on both sides. The effect is obviously negative, and even more. This negative effect is achieved after this all compression algorithm ran on that device, exhausted CPU, which made the device unable to process the network packets that it should be processing. So it's like a black hole effect. The more traffic you would like to optimize, the worse it gets. What's the remedy? It's very simple. Just disable optimization in those applications which you are supposed to optimize. And it's, yeah, and it's all back then in control. Why? It's because of those applications that are consuming the bandwidth most are not typically those that are business critical. Those that are consuming the bandwidth most are HTTP, HTTPS, with all this delivery of also now the modern content like the active content that single page applications, the multimedia applications like SMB or alike file sharing. They are also consuming the network most, email and so forth. All those optimization controllers are using just optimization algorithms for those, not for SMB. So be careful what you are doing. Why looking at network is important, just to summarize it. So we have been talking about the loss rate as the effect that makes the application delivery slow. If you look at this kind of chart, it really exemplifies that through this line, which as a corridor makes you really think how important that could be. Look here, it's a logarithmic scale, and here is the total loss rate that we see on the network, and here is the response time that we can observe. That's an analysis of the large number of transactions and connections that are occurring all the time, and you can see this devastating effect of the packet loss rate. The poorer the network quality, that means loss rate is occurring, the longer is the wait time, and it's exponential. It's really getting large very fast. Just looking at this again from the perspective of this waterfall chart for the application that works pretty well on the network without a loss rate. If we apply loss rate, it really prolongs from like ending up in 3 seconds to ending up in 15 seconds. That occurs really, really fast. So the question is whether it is only the wide area networks and the internet, which inherently has some kind of packet loss occurring in there, and those things have to happen. You just have to be prepared for them with the right application optimization technologies and the right efficient design for particular networks. The reality says that it is not. This diagram that I'm showing here, it comes from within the data center. It's behind the load balancer. It's behind the load balancer, and what's occurring in there, you can see that we have some of the requests when a single packet loss is triggering what? 3 seconds, 3 seconds for transmission time. We have just learned about this an hour ago, and here you can see the practical example how devastating that could be within the data center on the load balancer. How this kind of loss can occur within the data center. Here's another example of the packet loss that can occur within the data center, this time on the database team. This is the load sequence chart of the database query cursor fetch. From the first request, when we have established the cursor, we see here 1 second delay in that fetch of the first record from the cursor. What would you think is the reason? Typically, you would think the database is slow. But when you look at the detailed measurements of the network performance of this database here, you will also notice packet loss, 1 second for transmission delay. In this case, the network has already been optimized, so they went from 3 seconds to 1 second. Nevertheless, one packet loss in the virtual environment where the database sits also has this kind of devastating effect on the application performance. So, how could the packet loss occur in the virtualized environment? Everything is in memory, there are no buffers, there are no routers and networks and cables and everything, no elements. In virtual environment, it's all about timing. If the timing is not right, not set correctly between the virtual machines and the hosts, you may actually encourage something that is called a virtual packet loss, where no loss really occurred because the packet hasn't been delivered on time to the receiver. And in those situations where we have already network steam, we may actually cause the client or server to think that the packet has been lost and trigger that retransmission algorithm while the packet eventually will arrive. The net effect is the same. Without looking at the network, you will never know what's going on with your application. So let me stop at this moment. If you have any questions,